Welcome to solving quadratic trigonometric equations. We're going to go through 3 examples in this video. So solve each trig equation on the indicated interval. So we have 2 sine squared x is equal to 1. Notice if we square sine that we will not end up with any negative values, and we get the following graph shown here at the right. And notice, instead of our usual 2 solutions, if we're solving for when 2 sine squared x equals 1, we see we have 1, 2, 3, 4 solutions on the indicated interval. So let's determine why that is. When you see a sine raised to an exponent 2 and the x after it, that's just another way of saying sine x all squared. First step to solve is to divide both sides by 2. And we end up with sine x squared is equal to 1/2. And then our next step is to square root both sides. But remember, when you square root both sides, you need to include a plus and a minus. And that leaves us with sine of x is equal to plus or minus 1 over the square root of 2. That is because we're going to square root both the top and the bottom of 1/2. Square root of 1 is 1, and the square root of 2 is root of 2. The rest is the same as all our other problems. First, let's look for the related acute angle. Notice this is a ratio from one of our special triangles, which tells us our related acute angle is pi over 4. In this question, notice we have sine of x is equal to plus and minus 1 over root 2. So we're looking for where sine is both positive and negative. So that means we're looking at all 4 quadrants. So therefore, we will have 4 principal angles. So we can be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So therefore, x1 is just equal to our related acute angle, pi over 4. x2 is equal to pi minus pi over 4. x3 is equal to pi plus pi over 4. And x4 is equal to 2 pi minus pi over 4. So x2 is 3 pi over 4. x3 is 5 pi over 4. And x4 is 7 pi over 4. So therefore, x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So because of the sine x all squared, we have doubled our normal number of solutions from 0 to 2 pi. So here's the graph of 6 cos squared theta plus 5 cosine theta minus 4. And we want to determine when this equation equals 0. From the graph, we can clearly see that's here and here. And let's look at why there are only 2 solutions for this quadratic expression. First of all, we need to factor this quadratic. And why is it a quadratic? Well, let's replace the cosine theta with x. And now we clearly see that this is a quadratic equation. The next step is to try to factor this equation. Otherwise, we'll need to use the quadratic formula. Factoring gives us 3x plus 4 times 2x minus 1. And then if we put cosine back into the equation, we end up with 3 cosine theta plus 4 times 2 cosine theta minus 1 all equals 0. And just like a quadratic, we're going to solve for where each of these factors equals 0. Isolate these expressions for cosine. So let's start with cosine theta equals negative 4/3. If we go through our regular steps and try to find the related acute angle, cos inverse of positive 4/3, you see this will not work. Why won't it work? Remember that the range for cosine is from -1 to 1, and 4/3 is greater than 1. However, we know that cosine theta equals 1/2 is a ratio from our special triangles. So we have a related acute angle is equal to cos inverse of 1/2, and 1/2 is a ratio from one of our special triangles. And that tells us our related acute angle is pi/3. Since cosine is positive, we know there are solutions in quadrant 1 and quadrant 4. So let's draw our two principal angles. And finally, let's determine the solutions to this equation. So therefore, we see that x is equal to pi/3 and 5 pi/3. And our last example. This time we're trying to solve for where cotangent x times cosine x is equal to 3 cosine x. So you can see cosine x is our red graph, and cotangent times cosine is the blue graph. We have 1, 2, 3, 4 solutions from 0 to 2 pi. So let's look at how to determine these 4 solutions. First step, we have to use an identity. And the identity for cotan of x is cosine x over sine x. Let's bring the cosine x to the left side, so always bring all your terms to one side. In order to solve this equation, since we have a fraction, we'll need to rewrite it as one term. So we can say our common denominator is sine of x. So we're going to multiply the 3 cos of x by sine of x over sine of x. So you see we get cos squared x minus 3 cosine x sine x all over sine x. We can multiply both sides by sine x since we're solving an equation. We just need to remember that we can't have any solutions where sine x equals 0. And that means we can't have 0, pi, and 2 pi as a solution, because that would make this equation undefined. Alright, notice we have a common factor of cosine x, so let's factor that out. If we remove a factor of cosine x, we are left with cosine x minus 3 sine of x equals 0. Again, if you're unsure how we did that, if I replace cosine x with x, I get x squared minus 3x, and if I say sine is y, notice there's a common factor of x, which leaves me with x minus 3y, which is equivalent to what we have over here. Next, we set each factor equal to 0. So I need to determine where cosine x equals 0 and where cosine x minus 3 sine x equals 0. Let's start with cosine x equals 0. So if you see cosine x equals 0 or plus or minus 1, the quickest way to determine the solutions is to use the base graph. So let's look at the base graph for cosine. The base graph looks like this. So we're looking for where it equals 0, and we see it equals 0 at x equals, so 0 to pi, so half of that would be pi/2, and from pi to 2 pi, so the midpoint of that would be 3 pi/2. So far we've got 2 of the possible 4 solutions. Alright, let's start with the second one. So first of all, I'm going to move the cosine x to the other side. So I get negative 3 sine x is equal to negative cosine x. Next, I'm going to divide both sides by cosine of x. So I end up with negative 3, and sine over cosine is equal to tan of x, which equals negative 1. So when you have a sine and a cosine of degree 1, the best thing to do is try to get a tan x out of the expression. Last step is divide both sides by negative 3, and we get that tan of x is equal to 1/3. Now we can solve for the other two x values. Notice this is not a ratio from a special triangle, so our related acute angle will be equal to whatever the tan inverse of 1/3 is equal to. Since it's positive, we're dealing with quadrants 1 and 3. And now we can solve for x. So therefore, x is equal to the tan inverse of 1/3, and our second x value is pi plus the tan inverse of 1/3. So therefore, x is equal to, well, we have pi over 2 and 3 pi over 2 from our first equation, and using our calculator, we'll see we will get 0.322 radians and 3.463 radians for our next two x values. And notice none of these solutions are equal to 0, pi, or 2 pi, our restriction from above, which means they're all solutions to this equation. Here are some questions I suggest you try. And for question 14, you will need, or you may need, the following trig identity. Sine squared x plus cos squared x equals 1. Good luck.